Good morning, students. Thank you so much, students, for clicking on my video. I'm your Nagini ma'am, chemistry mentor. In today's section, I'm going to discuss about the Paulis exclusion principle and Hund's rule, students. These two principles are in atomic structure there, Nana. So, atomic structure lessons, 11th class, first PUC student, second lesson. Okay, now in the previous video, I discussed about the Aufbau principle, students. Now in this section, I'm going to discuss about Pauli's exclusion principle and Hund's rule. Now, first of all, what is Pauli's exclusion principle? Now, see, students, Pauli's exclusion principle. What is Pauli's exclusion principle? See, Nana, no two electrons in an atom can have the same set of values for all the four quantum numbers. No two electrons. What is the definition, students? No two electrons can have the same set of values for all the four quantum numbers. For all the four quantum numbers. Clear, students? What is the definition? Pauli's exclusion principle. What's it, students? No two electrons can have the same set of values for all the four quantum numbers. So we know that four quantum numbers: principal quantum number, azimuthal quantum number, magnetic quantum number, spin quantum number, n, l, m, s values. So no two electrons can have the same set of values for all the four quantum numbers, students. For example, I am taking here helium atom, Nana. Here helium atom. Helium atom has two electrons, correct? In 1s orbital. For example, students. Example, helium. Helium atomic number 2, electronic configuration 1s2. Correct? That means in 1s, how many electrons will be there, students? In 1s orbital, 2 electrons are there. Correct? So here 2 electrons are there, students. So first of all, I'm going to calculate the quantum numbers for 4 quantum numbers for the first electron, this one. Okay, Nama? So this is the first electron, students. For first electron, this is the first electron. Okay, and this is the second electron. Okay, Nama? So now I'm going to calculate 4 quantum number values for the first electron. Clear? Quantum numbers. Quantum numbers for the first electron. So what are the 4 quantum numbers, students, for the first electron? So what you have to take quantum numbers n, l, m, s values. N equal to how much? Now see, students, here 1s subshell, now 1s orbital. So in 1s orbital, this number indicates the principal quantum number. N is equal to 1 over. Next one, L value, azimuthal quantum number. We know that azimuthal quantum number L value, students, for S subshell, 0, P subshell 1, D subshell 2, and F of 3, Nana. 0, 1, 2, 3. Are you clear? So these are the L values. Now here what is there? S there. So for S subshell, what is the L value, students? 0. So that's why L value is 0. Next, M value. What is M? Azimuthal, L is azimuthal quantum number. M is equal to magnetic quantum number, students. So what about the M value, students? M value, what are the M value, students, for S subshell? M value for S subshell, how much? 0, Nana. S subshell 0. Are you clear? M values for S subshell 0. Okay, for P subshell it is having the different values, students. So that means -1, 0, +1. For D subshell, -2, +2, 0. Okay, sorry, -2, -1. Sorry, here I am writing -2, -1, 0, +1, +2. Okay, so these are the d subshell. Okay, now these d subshell orbitals in d subshell, because 5 orbitals will be there, so that all 5 orbitals values, students. Clear this one. And coming to the f orbital, in f subshell, students, total 7 orbitals will be there, so that's why m values are -3, changing from -3, -2, -1, 0, +1, +2, +3. So these are the m values. Okay, students, now see then, here m value, magnetic quantum number for s subshell is 0. Are you clear? 0. So that's why 0, because 1s na. Next, what about S value, spin quantum number? Which electron we are calculating? First electron, means clockwise direction. S is equal to how much? Plus half kada, electron is like this. This is a clockwise direction. So that's why it is plus half. For first electron we calculated. So S is equal to plus half. Okay. Now I'm going to calculate the quantum numbers for second electron, students. For second electron. So what are the quantum numbers? Quantum numbers for the second electron. Now what are the quantum numbers, students, for the second electron? Second electron. Now this is the second electron, anti-clockwise direction, students. So for this electron I'm going to calculate 4 quantum numbers values. Now see then, first n value, n is equal to how much? So n is equal to, this electron is present in 1s orbital, so n value is equal to 1, 1s na. So 1 indicates, this number indicates the shell number, so n is equal to 1. Next, L is equal to, azimuthal quantum number. For S subshell, azimuthal quantum number value is 0. So L equal to 0. Next one, M value, magnetic quantum number. Here S subshell is there, so that's why M value also 0. So M is equal to 0. What about S value, spin quantum number? For anti-clockwise direction electron, minus of, correct? So it is anti-clockwise direction, so that's why its spin is equal to -1/2. Now see, students, here two electrons are present in the same orbital. Here two electrons are having the same 4 quantum numbers, students. No, n value, L value, m value, 3 quantum numbers are same, but spin quantum number is different. One is having the plus of, another one is having the minus of. Are you clear, students? So this electron is having plus half, this electron is having minus of, S value. Are you clear? S value is plus half and minus half. So that is the definition of Paulis exclusion principle. No two electrons can have the same set of values for all the 4 quantum numbers. Yes or not? Here in 2 electrons are having the same 4 quantum number values? No. Only 3 quantum number values are same. Another 4th quantum number, spin quantum number, is different. Are you clear? So that means the 2 electrons present in the same orbital, the 2 electrons do not have the same 4 quantum numbers. That is calling as Pauli's exclusion principle. Understood, students? Now I am going to discuss about the Hund's rule. Next rule, Hund's rule. See, Nana. Hund's rule. Now, what is the Hund's rule, students? So, pairing of electrons. So, first of all, definition, I will write, Nana. Pairing of electrons in the orbitals belonging to the same subshell means what we are taking subshells P, D and F also we can take P, D or F subshells. Okay, now P, D or F does not take place does not takes place until each electron, until each orbital each orbital has got one electron, students. That means each orbital is singly occupied until each orbital is singly occupied. Once study, students, this definition: pairing of electrons in the orbitals belonging to the same subshell. Same subshell means p subshell, d subshell, f subshell. In p subshell, how many orbitals are there? 3 orbitals. We know that p subshell, how many orbitals? 3 orbitals will be there. In d subshell, how many orbitals? 1, 2, 3, 4, 5. 5 orbitals. In the F subshell, total 7 orbitals will be there. 1, 2, 3, 4, 5, 6, 7. Correct? Total 7 orbitals will be there. Understanding, students? So in these orbitals, PDF orbitals, so pairing of electrons, how to takes place, students? Pairing of electrons does not takes place in the same subshell until each orbital is singly occupied. That means electrons, first we have to fill single electron. After still remaining electrons, we have to pair the orbital, students, pair the electrons. Understanding? See here one example I will discuss, students, to explain the Hund's role. I am going to take one example, students, nitrogen. Suppose nitrogen I am taking. What is the atomic number? Nitrogen 7. Electronic configuration 1s2, 2s2, 2p3. So in 1s2, how many electrons? In 1s, 2 electrons. In 2s, how many? 2 electrons. In 2p, how many, students? This is the 2p. How many electrons are there? 3 are there. So these 3 electrons, how to fill, students? According to Hund's rule, PDF. Okay, because they have the orbitals. Understanding? Same subshells. So p subshell is having the 3 orbitals. So in 3 orbitals, how to, single orbital is there, we can write directly 2 electrons to it. But here 3 electrons, how to fill in 3 orbitals? So in 3 orbitals, so first we have to fill each orbital. In each orbital, you have to take single electron first, like this. Are you clear? Single electron you have to take 1, 2, 3. After completed 3 orbitals, okay, after completed 3 orbitals only, single electron with a single electron, then remaining electrons you have to pair nana here. Understanding? So here only 3 electrons are there, like that's why you have to take each orbital, you have to fill with single electron. Okay, now if suppose if I fill like this, 3 orbitals, 3 electrons, na 3 electrons means 1, 2, 3, it is wrong. Are you clear, students? This is the correct one. Understanding, students? So like this you have to fill. That means in each orbital, in the subshells, PDF subshells, each orbital first we should fill with the single electron, then the remaining electrons you have to pair. Understanding, student? We have to do the pair, students. Okay, this is a nitrogen. Now I am taking one more example, students. See here another example, oxygen I am taking. What is the oxygen atomic number? 8. 1s2, 2s2, 2p4. Correct? 1s2, 2s2, 2p4. In 1s, 2 electrons. So in 2s, 2 electrons. So in 2p4. 2p means how many orbitals will be there? 3 orbitals. Here 4 electrons are there. How to fill? First, in each orbital in the p subshell, first should fill with single electron. So that means 1, 2, 3. Single electron we filled. So all orbitals we filled with a single electron. Then how many electrons completed? 1, 2, 3. 3 electrons completed. Now that 4th electron we have to take the pair. Are you clear this one? If 5 are there, now I one more you see, oxygen. After another example is nitrogen. Now see, students, nitrogen, nitrogen, oxygen. Now I am taking fluorine, students. See here, fluorine atomic number 9. 1s2, 2s2, 2p5. That means in 1s orbital 2 electrons, in 2s orbital 2 electrons, in 2p orbitals 5 electrons are there. That means 5. First, according to Hund's rule, each orbital in p subshell should filled with a single electron. 1, 2, 3. And how many are there? Still 5. Total 5 are there. Here 3 electrons completed. Now 4th and 5th electrons, how to take here? 4th electron. This is the 5th electron. Are you clear, students? So like this you have to take understanding. So that means first in each orbital we have to fill the single electron, remaining electrons we have to, then afterwards we have to go to the pairing, students. Are you clear? So that is the Hund's rule, students. Understood, Amma? If suppose here this 5 electrons, if I fill like this is 2p, 5 electrons are there here. 5 means 1 2 3 4. Okay. See here 1 2 1 2 3. Only here I am taking 3 third electron. Here no electron. Here 4 5. This is correct? No, it is wrong. Are you clear? So we have to follow this rule. In the case of p subshell, d subshell and f subshells, they have the orbitals 3 5 7. In these orbitals, first each orbital should fill with the single electron, students. Are you clear? Single electrons, and the remaining electrons you have to take the pair. Clear, students? This is about the Hund's rule, students. I hope you like this video, students. In this section, Paulis exclusion and Hund's rule both I discussed, Nana. Okay, I hope you like this video. If you like this video, please like, share, comment and subscribe my channel, students. Please support me. If you are supporting me, if you supported me, then I will do still more videos I can do, Nana. Please try to understand. Please support me, students. Please subscribe my channel. Please share to your friends. For them also it will be helpful. Please, thank you, students.